Let's look at the absorptive state, the fed state. So you've got lots of lots of fats, right? Yes? So you know the fatty acids and your glycerol, along with lipoproteins and cholesterol, eventually form those chylomicrons. We'll talk about them again in a couple minutes. And so the chylomicrons, these are going to be the circulatory system. The lymphatic system first, and then eventually we'll go to the liver, and then get thrown out into the circulatory system. And then there are lipases that are running around in the blood, in the circulatory system. And these lipases will break these chylomicrons down, eventually the triglycerides down into the fatty acids and your glycerol. So these come back again in the adipocytes to form your triacetyl. Okay, it's going to be in your fat cells. So you eat too much calories, we have too much ATP through cellular metabolism. This is all regulated by cellular metabolism. So, because you're not going to eat just a cube of butter. You're going to eat butter with, bread or tortillas or whatever. So you're going to have some fat along with carbohydrates. The carbohydrates are going to go through cellular metabolism. You're going to produce ATP, you produce NADH2, you produce pyruvate. So as those levels rise, then the body is going to then shut off the cellular metabolism pathway. We don't need any more ATPs. We don't need any more pyruvate. So we're going to, therefore, not waste this, we're going to store it. So that's what the fats do. So after digestion, absorption, eventually the fat's going to be stored here until we need it again. And the assumption is that we need it again, but unfortunately in this country and many of the developed countries, obesity and overweight is going to, it's a huge problem because evolutionarily we do this, but we never expend it, we never go the opposite way. But we're going to talk about it when we do the opposite way. Okay? So sometimes glycerol, this glycerol right here, this glycerol portion sometimes can be converted to pyruvate. And you know pyruvate can be converted to glucose, and this can be stored as glycogen. So excess fat might be stored as glycogen. Okay, so this is during the absorptive state. Okay, but let's say we have a good balance, we haven't eaten for a number of hours, and now we're going to go to the post-absorptive state. So we're going to see what happens. So you know that the fatty acids and glycerol, so fatty acids and the glycerol from your adipocytes. So you know the lipases, because we need fatty acids and glycerol. And usually these fatty acids are going to take a different route than the glycerol. They're going to be converted into acetyl chains of fatty acids, and then they be converted into acetyl coenzyme A, and then they will be used, they will go into the Krebs cycle. part right here is called beta oxidation. So I've simplified it. There's a number of steps in here. CO2 involved a little bit, but basically the fatty acids is broken down to little 2-carbon chains and gets converted into acetyl coenzyme A, and then we'll go to the Krebs cycle to make ATP because we're a post-absorber. Once we go in the Krebs cycle, we want to make ATP through chemiosmosis. All right, do you see that? Right, so, well, okay, sorry. Can you still read the Krebs cycle ATP? Yeah, okay. Okay, so now for the glycerol portion, it's going to be converted to pyruvate, and instead of going backwards, it's now going to go forward. And so this is how you use fat to make ATP. So when you go on a diet, you want to lose weight, this is exactly the process that happens. Fatty acids take a slightly different route, the glycerol takes a slightly different route. So they all end up in the Krebs cycle, and they all produce ATP. So you lose weight out of those adipocytes, or you lose fat out of the adipocytes. Yeah, so the fatty acids enter as acetyl coenzyme A, the glycerol enters as pyruvate. Yeah. So that's the way to just remember that. So we see a lot of things enter as acetyl coenzyme A, a lot of things enter as pyruvate. Okay, so let's say you are on a diet and you really cut your calories down really, really low and to like 500 calories a day. Then this process is going to happen really, really fast. And so one of the things that is going to happen is that where some of this oxidation or breaking down of this fat is going to produce ketone bodies. Okay. So right here, the acetyl coenzyme A is going to get converted into ketone bodies. Here are ketone acids. Okay. And an example would be acetone. Am I too low? Yeah. Sorry. Do you want me to put it up here? So, okay, so acetyl coenzyme A, here we go. So now, instead of going directly to the Krebs cycle, it's going to, the acetyl coenzyme A is going to produce acetone body, ketone bodies, such as an example of acetone. Is an example. These really are acids. And interestingly, these ketone bodies can supply the brain, supply the skeletal muscles as a source of ATP, the heart. And what they do there is that these ketone bodies, acetone will come, and then they will then, in their cells, convert it back to acetyl coenzyme A. Into the Krebs cycle. They will produce ATP.
Can you repeat the last one again?
So when fat production, when fat catabolism happens really, really rapidly, much more than we can normally go through the process, the ketone bodies are converted. So instead of acetyl coenzyme A, it overloads the Krebs cycle because you're just producing a heck of a lot of acetyl coenzyme A from the breakdown of fats. So what the body does, what the cell does, is it converts it into ketone bodies instead. Some of the excess acetyl coenzyme A into ketone bodies instead. And this basically spares the fat. And so, so that you don't have, again, a huge amount of fat metabolism. So the ketone bodies can be used by the brain, skeletal muscles, and heart. And so they will then, so this will cross the blood-brain barrier, and so and then there, in those cells here, they'll convert the acetone into acetyl coenzyme A again, and then have it through their Krebs cycle. So they'll use it as their source of quote-unquote glucose for a while, and so but they're gonna use amino acids, so if you're in starvation, if you're basically on an island and you have no food, you're going to break down those amino acids for ATP, you're gonna break down the fats for ATP, and you're gonna produce ketone body, because the brain's saying, I can run on ketone body, I don't need a lot of glucose, you're not giving me any glucose anyway, and we don't want it to kill the heart, because a lot of people who have anorexia, in terms of starving themselves, they die because of heart failure. They die of a heart attack, because their heart, as the amino acids in the heart, the muscle is broken down, because they basically are skeletal. So, but here's a way evolutionary of the body saying, especially the brain, saying, let's not use up all the fat, let's not use up all the muscles, tissue for ATP, and so therefore let's have a balance, and so they use this instead. Okay? All right? And so, therefore, someone who has diabetes 1, for instance, who doesn't produce any insulin, they can't bring the glucose to the cell because you don't have those glute transporters that get inserted into the cell. So the glucose can't come into the cell, so therefore they don't have any glucose as a source to make ATP. So they'll use their fat. And that's the people who have untreated diabetes 1 are thin. They don't have any fat, so their fat, they will go through this process here. And so they can go into what we call ketoacidosis. They can go into acidosis in the body and actually be deadly. The acetone right here for someone who's in ketosis, normally whether they're diabetic or not, say you are on a very low calorie diet for a week or two, you're going to have an acetone breath. Your breath's going to smell really bad because what you're breathing out are these ketone bodies. Okay? And those of you that may have heard of the Atkins diet, one of the things that he advocated, he had died of a heart attack, by the way. But anyway, one of the things he advocated was to buy little sticks to test your urine for ketone bodies. And so every morning you would be peeing on one of the little strips there. We're going to do that in the urine analysis. And what you were testing for were ketone bodies. And that told you that you were burning fat. And so for him, that's good, because that's why you were on the Atkins diet.
So you put your body in ketosis?
Yeah, so your body was in ketosis. That's right. But I say that he died of a heart attack because the Atkins diet is a low carbohydrate, high fat, high protein diet. So, okay, so we're all right here for the fat metabolism. We're comatose. Not quite. Let's see. Oh, let's do